Hey everybody, we are going to be classifying polygons, so we're in section 1.6. You know the deal, go ahead and write today's date and let's get started with some vocabulary. Our first word is polygon, and here are some pictures of polygons. So a polygon is a closed figure with segments as sides. So the sides of a polygon would be a segment, and you've seen polygons before. Let's talk a little bit more about what they're made up of. So the side of a polygon would be the part that's the segment. So this particular polygon has 5 sides. This one has 1, 2, 3, 4, 5, 6 sides. This one has 4 sides. And of course, we can see that this one has 3 sides. So the next concept is the idea of a vertex. That's the singular, or when we're talking about one, we have a vertex, and vertices when we're talking about more than one or many. That's the joining places of these segments, where these segments meet, the corner points of our polygon. These are called vertices, or an individual one is called a vertex. So everywhere that I have red, that is going to be a vertex. So the vertex or vertices would be the endpoints of the sides of a polygon. We've got 2 other words here. This is going to describe or classify polygons. Polygons can be either convex or concave. These examples of polygons, these guys are called convex. Notice that all of the angles are on the outside, the exterior. We could even look at the fact that if I followed the line of any of the sides, I always stay outside of the polygon, okay? So these are convex. Let's look at what concave looks like. Concave is going to look like this. Notice that if I were to continue the side of these particular polygons, it cuts to the interior of the polygon. So concave looks like this. When I think about concave, I almost think like you can go in to the polygon kind of like a cave. Concave. Our next word is n-gon, which is going to seem really strange, so let me explain a little bit what that means. If I had a triangle, which is a polygon, I could call it a 3-gon. Give me, say, a rectangle or some 4-sided figure. Let me make that a 4-sided figure. I could call that a 4-gon. Let's say I had this guy over here. What would you call it? Look carefully at the number of sides. You can call it a 6-gon. I know we've got names for these guys, right? But n-gon is our way of talking about a polygon with n sides. I'll write that down for us. So an n-gon is a polygon with n sides. If I had a 3-gon, that's a polygon with 3 sides. A 4-gon is a polygon with 4 sides. A 6-gon is a polygon with 6 sides. N is a variable, so that means that that number can vary or change. The next term is equilateral. Equilateral means a polygon where all the lateral or sides are congruent. Notice these 3 polygons have side lengths. Each of the segments are the same length. And when that's the case, we use little marks like this to say that these sides are congruent to one another. Notice I'm using 2 here. So every segment that has 2 marks are saying that those are the same length. And same thing over here. Let me use 3. So I'm saying every segment in this particular picture is equivalent. So all of these segments are equal, all of these segments, meaning it's equilateral. All of the sides are congruent. So a polygon with sides that are congruent or sides that are equal, that would be equilateral. The next word is equiangular, and I'm pretty sure you can guess what that means. When we talk about equiangular, we're talking about polygons where all of the angles are congruent. So by me marking these curves around these angles, I'm saying all 5 of these angles are congruent. 1, 2, 3, 4, 5. Yes. So I'm going to go ahead and mark that, and I want you to write down what equiangular means. So equiangular is a polygon with angles that are congruent. Notice I used a little congruent symbol here instead of writing out the word. We'll do that from time to time. So notice I've also marked all of these angles being equivalent to one another. Our final word, but not our final bit of notes, our final word is regular. A regular polygon has both equilateral and equiangular properties. Let's go ahead and look at those. So regular polygons are both equiangular and equilateral, so we could use the markings where we mark all the sides equal and all the angles equal for each of these figures. That's what a regular polygon is. Regular polygons are polygons that are both equilateral and equiangular. So the next thing we need to talk about is names of polygons that we're probably familiar with. So the first one we'll talk about is the triangle. We know it's got 3 sides. Then we have the quadrilateral, which has 4 sides. So any 4-sided figure is called a quadrilateral. We also have the pentagon, which is a 5-sided figure. Hexagon, 6 sides. Let's scooch up a little bit. Let's see if we can get it there. Septagon or heptagon. Can also be called a heptagon. It has 7 sides. We've got an octagon, which has 8 sides. We're going to go on to 2 more, and then we'll talk about an engon. So the last 2 named one that we're going to talk about in this video is the decagon, which has 10 sides, the dodecagon, which has 12 sides, and then finally the engon, which we talked about before, which has n sides. I'm going to probably put something up on our classroom wall so we can have access to these words if we're not familiar with them. Let's go ahead and begin the examples, guys. Now that you're in the example section of your notes, let's go ahead and take a look at example 1. It says, tell whether the figure is a polygon or whether it is whether it's convex or concave. So as I look at this one, this looks like it's not quite a polygon because a polygon's not supposed to have any lines or sides inside. So we could say this is 2 polygons together, but honestly, this whole shape is not a polygon. So I'm just going to go no. This one is a polygon. It's got sides that are all segments and it's closed. And also I can see that if I were to extend these sides, none of them would cross in the interior. So this is not only a polygon, but it's also a convex polygon. This guy over here looks like a polygon. It's got some sides, it's closed, but then when I look kind of closer, I don't know if you guys can see it, that's not really a straight segment over here. That's kind of a curved shape, so it's not a polygon. Doesn't fit the criteria. And let's go ahead and look at the last one, D. In part D, we're looking at it. It has segments for sides, so that's definitely a polygon. But when I extend one side, notice that sometimes when I extend a side, it actually crosses into the interior, which lets me know that that is concave. It goes inside like a cave. So this is a polygon, but this is a concave polygon. Example 2 is asking us to classify the polygon by the number of sides, then tell whether the polygon is equilateral, equiangular, or regular. Explain your reasoning. So we're going to just talk about our reasoning. I won't verbally or write out the written explanation, but when I look at this polygon, it is a polygon. I see that it has 6 sides. So 6-sided polygons are called hexagons. The next thing I'd like you to see is that it's marked that all of the sides are congruent and all of the angles are congruent. So that means it's both equilateral and equiangular. And when it's both of those, we call it a regular polygon. So this is a regular hexagon. Over here, we have a 4-sided figure. 4-sided figures are called quadrilaterals. And so I'm going to write that down here. And the next thing we need to do is observe the side lengths. All the sides are not the same, so we do not have an equilateral situation here. But all the angles are also not the same. So it's neither equilateral or equiangular. This is just a polygon. It's just a quadrilateral. Over here, this last one looks kind of weird, so I'm going to zoom in a bit. So remember, we want to know if all the sides are the same length, and we do have all the sides that are the same length. So already I know that this is definitely equilateral. Now I want to figure out if it's equiangular. So we're looking at these angles, and they've got all these squares here, so I know that means that those are 90 degrees. However, the interior angle here would be this part. Would be the inside, not this outside angle. So when I'm looking at this, I know that this is not equiangular because the interior angles are not the same. This big angle in here and this other big angle, but then we've got these little angles, they're not all congruent. So this shape is called, let's see, how many sides do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a dodecagon and it is equilateral. Let's go ahead to our next example. Over here in example 3, we have a table that is shaped like a regular hexagon. Regular meaning all the sides are congruent and all the angles are congruent as well. The expression shown represents the side lengths of the hexagonal table. Find the length of each side. Okay, we can do that. So we are given that this side and this side, they're congruent. And this represents the length of this side, and this represents the length of that side. We know how to deal with this. We know that this is a situation where these two expressions must equal one another. Therefore, 3x plus 6 equals 4x minus 2. We're going to solve the equation like we know how to do. I'm going to choose my x terms to be on this side and my constant terms to be over here. I do not want anything but constant terms here. That means that 3x must go. When I move things from one side to another, they always change signs. So on this left side, I'm left with 6. 4x minus 3x is x, and I'm left with a minus 2. I'm almost done. On this side, I only want x terms. That means that 2 has to go. Again, when I move things, the sign must change to the opposite. This is a minus 2. That's going to be canceled out by a positive 2. I'm left with x is equal to 8. So far, so good, right? I've got that x is equal to 8. But they asked us to find the length of the side. What that means is we've got to substitute the 8 back into this expression in order to figure out what the length is. I can choose either expression because both of those sides are congruent. I'm going to go with the 4x minus 2. So since 4x minus 2 is equal to one of the sides, then I know that since I know what x is equal to, I'm going to plug that into the expression and I'm going to calculate what I have. So 4 times 8, thank you for being patient with me, minus 32 is equal to 32, minus 2 is going to give us 30. We're dealing with inches, so the length of the side of that table is 30 inches. That's it for your examples. Let me know if you have any questions. Make sure you copied everything down, and I look forward to talking to you guys soon. Take it easy. Bye-bye.